Hi dear students, myself Prabhavathy, Assistant Professor of Mathematics, A.D.M.COLLEGE for Women, Autonomous, Nagapattinam. Today I am going to tell how to solve second order linear differential equations with constant coefficients of homogeneous type. So dear students, today we are going to solve, as said before, second order linear differential equation of homogeneous type with constant coefficients. Okay. To move on to the problems, before we should know three things. What are they? First, if we write auxiliary equation, as we said in the last two modules, auxiliary equation will be of second order arithmetic equations. Okay. So it will have two roots. If the roots denoted by M1 and M2, if they are real and distinct roots, then the solution will be y equal to C1 e power M1x plus C2 e power M2x. Here C1 and C2 are arbitrary constants. Again, if M1 and M2 are real and equal roots, then the solution will be y equal to C1 e power M1x plus C2 into x into e power M1x, because M1 repeat two times. Okay. To get the independent solution, we have to insert x in the second expression. Okay. So the general solution will be of the form y equal to C1 plus C2x into e power M1x. If the roots are of the form complex numbers, that is m equal to alpha plus or minus I beta, because complex roots always occur in pairs. That is, if alpha plus I beta is one root, alpha minus I beta will be another root. Okay. So in this case, the general solution will be of the form y equal to e power alpha x into C1 cos beta x plus C2 sin beta x, where alpha is real part, beta is imaginary part. And in all the cases, the C1, C2 are any arbitrary constant. Okay, that's your wish. You can choose any type of C1 and C2. So if you are very well aware of this formulas, then we can easily solve the second order linear differential equations with constant coefficients of homogeneous type. So today we are going to solve this problem, d square y by dx square minus 6 dy by dx plus 8y equal to 0. So solution, the given differential equation, that is dE, is a second order, because the order is 2, linear differential equation with constant coefficients of homogeneous type. Here equal to 0, that's why this is homogeneous type. Here coefficients, here coefficient is 1, here minus 6, 8, they are constants. So it is known as constant coefficients. Okay. So first, students, try to convert this into this form, that is capital D form. That is, capital D is nothing but capital D power n is d power small d power n by dx power n. That is, if you put n equal to 1, that is capital D is d by dx. If n is equal to 2, d square is d square y by dx square. Okay. Then if you replace this, then this will becomes capital D square y. Second term will become minus 60y. Third term is plus 8y equal to 0. Okay. Now take y in all the terms, it is common. To the, you should always write this y in the right hand side only, should not write before to y, d. Okay. It doesn't make any sense. Okay. So d square minus 6d plus 8 into y equal to 0. The given equation converted in this form, so that you can write the auxiliary equation in a without any mistake and in an easy manner. That's why we are converting this equation into this form. Now let us write the auxiliary equation. What is it? So the auxiliary equation is, we will get it by replacing capital D by small m. So small m square minus 6m plus 8 equal to 0. Okay. Here y is the independent variable, dependent variable depending on the independent variable x. It should not be appear here. Okay. So the auxiliary equation. While writing auxiliary equation, you all should be aware that we have to replace only the capital D and write the equation. Should not write y in any place of auxiliary equation. So then we have to find the roots of this equation. You can use any method. Now by observing this 8 and 6, I am preferring the factor method. That is, I am going to factorize this expression into product of two linear factors. Okay. How will it be do? So for that we have to consider the last term, the constant term, that is 8. So 8 can be written as 4 2s are 8. Okay. Why we are choosing 4 and 2? So that 4 plus 2 will give us 6. Like that we have to choose the factor of 8. So 4 2s are 8 and here minus 6. So that's why I am taking minus 4 minus 2. So minus 4 into minus 2, it is minus into minus plus 4 2s are 8, plus 8 will come. And if we add minus 4 and minus 2, it will be minus 6. If we replace this equation by the linear factors, the linear factor will be m, that root, that is minus 4. Second factor will be m minus 2. So this equation becomes m minus 4 into m minus 2 equal to 0. And from this, if we solve this separately in these linear factors, we will get the solution as m equal to 2, m equal to 4. Okay. So now we are finding that the roots are all 2 and 4. So I am giving name for a 2 m1, for 4 m2. Okay. So the two roots are real. They are real numbers. And what about the character? They are unequal. They are not equal. Okay. So it is denoted by distinct. So you have to write the roots are real and distinct. So as we mentioned in the three properties formulas, so if the roots are real and distinct, what is the general solution? That is, the solution of the homogeneous type is sometimes called as complementary function. In short, CF. Okay. You may be asked in the questions, find the general solution, or sometimes you will be asked like, find the complementary function. So anyway, in both ways, you have to find the same method only. Okay. So here the roots are real and distinct. So the solution will be y equal to c1 into e power m1x plus c2 e power m2x. Here m1 is what? 2 as we chosen, plus c2 into e power 4x. So where c1 and c2 are arbitrary constants. So while solving this problem, you have to concentrate mainly on this, writing the auxiliary equation and solving the auxiliary equation. Then if you know the formula very well, then you can easily write the general solution, that is complementary function of this type of function. And this type of problems will be asked in semester examination as a 2 mark questions. Okay. Okay. Now let us solve this second one. D square y by dx square plus 16y equal to 0. This type of problems also will be familiarly asked in the semester examinations. Okay. So the solution, the given differential equation is a second order linear differential equation with the constant coefficients of homogeneous type, as we mentioned in the first problem. So here let us rewrite this equation as capital D square y plus 16y. Here dy by dx disappear. Okay. So here taking y outside, so d square plus 16 into y equal to 0. So the auxiliary equation is m square plus 16 equal to 0. So if we take plus 16 to the right hand side, we will have m square equal to minus 16 and minus 1. If we take square root, the square root of minus 1 is not a real number, isn't it? That's why I am replacing minus 1 by I square. So 16 can be written as 4 square. So m square is equal to 4i the whole square. So by observing this type of questions, you will maybe practiced or memorized that this type of roots can be solved this manner only. Okay, don't try for another methods, then you will get some complexity. Okay. So m square equal to 4i the whole square. So this will imply m equal to plus or minus 4i. So the roots are complex roots. Why it is complex roots? Because it is of the form, it is involving I, that is I is imaginary, that is here I is equal to root of minus 1. Okay. So Because students sometimes have some confusion, that is, it should be of the form alpha plus I beta, not like that. So here in this case, the roots are complex roots and alpha is 0. That is, real part is 0. If there is nothing, then you can take it as 0. And the imaginary part, while writing imaginary part also, students, please be aware that I coefficient, that is just you have to take 4. You should not write plus or minus and so on. Okay. You have to take this number only, 4. So hence the general solution is given by the formula y equal to e power alpha x into c1 cos beta x plus c2 sin beta x. Okay. Here alpha is what? 0. So e power 0x. Okay. So c1 beta is 4. c1 cos 4x plus c2 sin 4x. So e power 0x what? It is 1. So for y equal to c1 cos 4x plus c2 sin 4x, where c1 and c2 are arbitrary constants. This is the general solution, that is complementary function of the given differential equation. So this is another type. Okay. So the third problem, solve d square y by dx square minus 4 dy by dx plus 4y equal to 0. So the solution, again you have to write the given differential equation is a linear differential equation with the constant coefficients of homogeneous type. Then rewrite the equation as capital D square y minus here dy by dx term appear. Okay. So it is d minus 4 dy plus 4y equal to 0. Take y outside. So capital D square minus 4d plus 4 into y equal to 0. The auxiliary equation is m square minus 4m plus 4 equal to 0. Okay, from this equation you will get auxiliary equation by replacing capital D by m. So here this is of the form, by observing we found that m square minus 4m can be written as 2 into 2m. So 4 is nothing but 2 square. Okay, equal to 0. So this is a formula a minus b whole square format. So here a is m, b is 2. So m minus 2 the whole square equal to 0. This is of the form m minus 2 into m minus 2 equal to 0. That is m minus 2 equal to 0 and m minus 2 equal to 0. That is m equal to 2 and 2. Okay. You may be aware that from this you can directly write also. That is m equal to 2 comma 2. It's your wish. So maybe some students will be wonder why from this we will get 2 comma 2. That's why for that only I give an explanation, because some students we are writing like just to handle root, because if you solve this, if you substitute m equal to, you will get 0. So you may, so many of the students are writing like m equal to 2 is a root, not like that, because here it is a quadratic equation, it will have at most 2 roots. Okay, so that's why you have to write 2 roots. Here the roots are same, that's why 2 comma 2. So the roots are real and equal. So the general solution is CF is what? So general formula C1 plus C2x into e power the root, that is 2x. Okay, where C1 and C2 are arbitrary constants. So that is C1 e power 2x plus C2x into e power 2x. That is, in short, we write like this. Okay. So to ensure the independent solution, we are inserting x in the second place. Okay. So now we see the 3 types of roots and how to write the general solutions. Okay. Actually, our aim of this module is to solve this kind of initial value problems. That is, we have to solve the differential equation with the condition given like this: dy by dx equal to 0 and d square y by dx square equal to 2 when x equal to 0. For that only I recall that methods, and we solved 3 basic problems, okay, involving the 3 characteristics of the roots. So here the solution, first we are taking the given differential equation. It is of second order, homogeneous type and constant coefficients. I write that equation, so that is d square minus 2d minus 15 into y equal to 0. What is the first step? You have to mention what is its type, and second type you have to write the auxiliary equation. So the auxiliary equation is what? Here m square minus 2m minus 15 equal to 0. This can be factorized like this, that is minus 15 can be written as minus 5 into 3. So minus 5 into 3 is minus 15. Minus 5 plus 3 is minus 2. Okay, so if we substitute here, you will get m minus 5 into m plus 3 equal to 0. So from this, m minus 5 equal to 0 and m plus 3 equal to 0. So this will give you m equal to 5 and m equal to minus 3. So the roots are minus 3 and 5. So what is this type? This is roots with real and distinct. So hence the general solution is what? Y equal to c1 e power minus 3x plus c2 e power 5x. So this is general solution of this equation. You are asked to find the solution of this equation with the given condition. Okay, so you have to proceed further. So for that, we are taking this solution as equation number 1. That is, we are going to use the condition. So first, what are the conditions given? First, we have to be careful on that. For that, so given that dy by dx equal to 0 when x equal to 0. Whenever x is 0, you are giving that dy by dx equal to 0. And when x equal to 0, the second derivative d square y by dx square is also 0. So you have to separately see that condition. Okay. So from this y, you have to calculate what is dy by dx and what is d square y by dx square. Then we can substitute the condition. Okay. So how will you get dy by dx? So you have to differentiate that equation 1 with respect to x on both sides. You will get dy by dx. So c1 is constant. It will be same. E power minus 3x involving x. So what is the derivative of e power minus 3x? It is minus 3 into e power minus 3x plus c2 e power 5x is 5 into e power 5x. So that is, you will get dy by dx equal to c1 into minus 3 e power minus 3x plus c2 5 into e power 5x. So if we write like this, so minus 3c1 e power minus 3x plus 5c2 e power 5x. So this is equation number 2. Then we have to find d square y by dx. How will you get? For that, you have to 2 times differentiate this equation 1. Otherwise, you can differentiate this dy by dx one more time with respect to x. So dy by dx with respect to x, if you differential, we will get d square y by dx square. So here again the constant term is minus 3,1. We have to keep it as, if we differentiate e power minus 3x, you will get one more minus 3. So minus 3 into e power minus 3x plus again the second of 5c2 e power 5x can be given as 5 into e power 5x. So that is 9c1, 3 3s are minus 3 into minus 3 plus 9. So 9c1 e power minus 3x plus 5 5s are 25, 25c2 e power 5x. So let us keep it as equation number 3. So now we find y, that is general solution dy by dx, d square y by dx square. Let us call this as equation number 1, c1 e power minus 3x, c2 e power 5x and dy by dx as 2 equation. This is equation 3. Okay. So now you are going to apply the condition. What is the condition? When x equal to 0, dy by dx equal to 0. So substitute this, use this in equation 2. So by equation 2, this will give you dy by dx is 0 when x equal to 0. Put x equal to 0 in all the term. So here e power 0 is what? 1. So this will give you minus 3c1 plus 5c2. So this is one equation. Another equation, d square y by dx square equal to when x equal to 0. So in the equation 3, if you substitute this, we will get d square y by dx square is 2. LHS 2, RHS will be 9c1 plus 25c2 because these terms e power 0 will give 1. So now if we write these equations as equation 4 and 5. So what is equation 4? Minus 3c1 plus 5c2 equal to 0. Equation 5 is 9c1 plus 25c2 equal to 2. We have to solve these two equations for c1 and c2. So if you multiply the equation 4 by 3, what will you get? 3 3s are 9, minus 9c1, 3 5s are 15c2 equal to 0. Equation 5, we keep it as it is, and if you add these two equations, you will get 9c1 will get cancelled. 15 plus 25 will be 40 C2, right hand side 0 plus 2 is 2. So 40 C2 equal to 2. What then you need only C2. So if you take the 40 to the right hand side, so it is in the multiplication form. So if you get it, it will be in the division form. So C2 will be 2 divided by 40. So 2, if we divide by these 2 by 2, it is 1 by 20. So the value of C2 is 1 by 20. So by using this value or doing like the same process, also you can find the value of C1. Now I am going to substitute this C2 in equation 4 to find C1. So again rewrite that equation 4 here and substitute the, before substituting I am taking this minus 3 1 to the right hand side. So 3C1 equal to 5C2. So C2 is 1 by 20. So 5 into 1 by 20, that is 1 by 4. So 3C1 equal to 1 by 4. We need only C1. So take 3 to the right hand side. It will become C1 equal to 1 by 4 into 3, that is 1 by 12. So C1 value is what? 1 by 12. So now we are going to substitute these values C1 and C2 in this equation 1. You will get solution like this. Y equal to 1 by 12 e power minus 3x plus 1 by 20 e power 5x. This type of solution is called as particular solution, because you are giving C1, C2 values particularly. Okay, so it is called as particular solution. So this is general, this type of solution is general solution, and if you are giving condition like this, then you will get values of C1 and C2 if you replace this one particular solution of this given differential equation. So next modules you will see, we will continue solving the problems like this in some other methods. Okay, so I think now you understand the methods how to solve second order linear differential equations with the constant coefficients of homogeneous type. Thank you, students.